It's time now for 5.3, which is common factoring. This is the first type of factoring we'll be doing, and then in the next few lessons we'll be doing different types. But common factoring is always the first type of factoring that you look for. So let's just recall here, if we were to expand this, okay, doing the distributive property, we would have 3a times 2a, we would have 6a squared, and 3a times negative 5 is negative 15a. Now, what if I told you, though, I gave you this, and you had to get back to this? That's what factoring is. It's going backwards from the expanding. So if I was given this, would you be able to go back to that? We'll go through some steps on how you can figure that out. So again, common factoring is the first type of factoring you always look for. And what it is you're looking for is the greatest common factor, GCF. So if you look at these terms here, you're looking for the greatest common factor. So first you look for the coefficients, and then you look for the variables. So looking at the coefficients, 3, 9, and 15. What is the most that you could factor out? What is the most that you could divide each of the terms by? So let's say we said 9. Again, we want it to divide perfectly. We do not want fractions or decimals. So if we divide this, all the terms by 9, 3 divided by 9, that already didn't work. There wasn't enough. So the most that we can factor out of 3, 9, and 15 is 3. Then we want to look for the most that we can divide out of the variables. We have x squared. So there's 2 x's to give here, x to the 5 x's to give here, and 4. So if we tried to take, let's say we thought it was x to the power 4, the most we could take would be x to the power 4. Here, this has 5 x's to give. Okay, so we could take 4 of them. This one has 2 x's to give. So if we're trying to take 4, this doesn't have enough x's to give. So 4 is too many. X squared, though, we could take 2 from this one, 2 from this one, and 2 from this one. So x squared is the greatest common factor for the variables. So the greatest common factor in total is 3x squared for this polynomial. So what the method is you find what your GCF is, and that would go in the front. So in the example we had there, and then whatever you get from dividing, so you take your polynomial and you would divide it by 3x squared, divide it by 3x squared, divide it by 3x squared. Whatever you get after this division, that's what would go in the bracket here. Okay, so let's do a couple examples here. So if again we look for what's common, for the coefficients, the most that's common between 15 and 5 to divide would be 5. And now let's look at each letter part by part. So the a cubed, and this is a, there's no exponent, so we assume that it's 1. The most a's we could take, this one can give 3, this one can only give 1. So the most we can take is a to the power of 1. And b's, b to the power of 1, b to the power of 2, the most b's we can take is just 1b. So we took the part that we're dividing, our GCF, and we put that in front. Whatever we get from this division, it's going to go in the bracket. 15 divided by 5 is 3. A3 divided by A1. Remember exponent laws, we are dividing, so we subtract the exponents. So we have A squared. B to the 1 divided by B to the 1, it goes 0. So that's gone. And now if we do the next term, plus 5 divided by 5 is 1. A1 divided by A1, that goes to 0, so that's gone. B squared divided by B1, subtract the exponents, and you get B to the power of 1. Now we generally don't write this one or this one here, so it would just be 5AB for proper form, and then plus B. And so that's what it would be factored. Now how can you check this? Well, we've had lots of practice at expanding. Go back and expand it. Make sure that you get back to that first thing that you started with. All right, here's another one. Let's look for what's common. 9, 27, and 18. So what's the most common? And you can try this one on your own, and you can check back your answer in just a second. So hopefully you found that as your greatest common factor. And so if we factor this out, we have 9x squared, y squared, and what's left? 9 divided by 9 is 1. X cubed divided by x squared, subtract the exponents, x to the power of 1. Y2 divided by y2, it's all gone. Plus 27 divided by 9, so that would be 3. And then we have x squared divided by x squared, so that part's gone. Y5 divided by y squared, and so that would give you y to the power of 3 minus, and then this is 2x squared y4. And again, if you're unsure, you can expand and you can check that you get back to here. Here's another type where we have, again, looking for what's common with the numbers. Well, 4 is common between all of them. Now let's look at x squared, x, and no x. So in this case, this doesn't even have an x to give, so we can't even make a common factor of x. But we can factor that 4 out, And so what we're left with is 4 divided by 4, so that just gives us x squared minus just the x, and then 4 divided by 4 is minus the 1. And this is as far as we can go at this point. This one is a little bit trickier because we're not just looking for the number and the letter that's common. We're actually looking for a whole group of things that's common. So see how this is one term and this is one term. And what's common between each of those is notice that 3a minus 5 and 3a minus 5 is common between both. So we're going to divide that whole thing out for both. So it was a whole expression that was in common instead of just a number and a variable. So if we divide this, the part that we're dividing goes in front, and then we would divide that. So those are the exact same thing. So just like 2 divided by 2 would be 1, 3a minus 5 divided by 3a minus 5 is 1. So we're left with 2b minus 3, and then that one's factored. So if you have any questions about common factoring, make sure you write them down. And this definitely takes practice, so make sure you practice, practice, practice. See you in class.